bit as I talk about the transformations for this class. Well, we're looking at basically this formula: A, F, B, so parenthesis B, parenthesis X plus H plus K. So, and these quantities A, B, H, and K, each of these is a different transformation. So, for example, the A is a vertical stretch. And what's really going on with this vertical stretch is we are multiplying the Y value, that's what makes it vertical, by A. So any Y value in your whole graph gets multiplied by A. Okay, so the B, so that's this one. Your B is a horizontal compression. And what's going on there is you're going to be multiplying your X values by, this is a little bit of a twist, 1 over B. So there's this inverted relationship between B and what you actually multiply your X's by. That's what makes it a compression, it's because of that inverse relationship. Okay, the A, so that would be, H is next, so H is a shift, is just a shift to the left. And you're gonna basically add to X the value negative H. So again, there's kind of a flip here. It's a positive H in the formula over here, but it's a negative H over here. And then finally, the K is a shift up. And that's you add to the Y value, the value K. So there's, plus K, that one doesn't switch. Now let me just kind of briefly talk about, okay, so why is this a negative H here? Why does the H flip and the K not? And why does the B flip, but the A doesn't? Well, that goes back to that very first problem we did so remember this? How if you move a graph like f of x equals x, so if you move this green graph to the right, it's actually getting smaller in a way. And another way to think about this is, let me just redraw it really fast. So another way to think about this is, we move the thing right, you move everything to the right, and then you can ask yourself, well, my old value was over here. What do I need to do to my new value to get back to my old value? Well, you need to subtract, right? Sorry, I'm just a little bit, there's something else I wanted to say about this and I'm not quite grasping it. So I think this is probably the most confusing thing about transformations, at least to me, is why does the H flip in this formula? So why do you go, I mean, if you can just remember that it does, you'll be fine on the problems, but just understanding why I think is kind of the trickiest thing. So why does the H flip? Well, so for example, a shift to the right is actually a -3. So why is that? Well, what you want to do is, okay, I might be too far down the rabbit hole, so I apologize if I'm not making a lot of sense, but let's just say this is 7 and this is 4. And that's not quite to scale, but so kind of what's going on? Well, with this formula, this is the formula for the blue graph right here. So if you subtract 7, so we want 7 to be the same value as 4 for just f of x. Well, how do you make that work? Well, if 7 is supposed to do the same thing as 4, we better be subtracting 3, right? And that is why, okay, so I think that's what I wanted to say. I apologize if that didn't make a lot of sense. But basically, you're trying to get from 7 to 4, you want to kind of normalize it, go back to the original, and you have to subtract. That's what's happening here. We need to, if we're adding h in the formula, that means we must be shifting to the left. And if we're subtracting h in the formula, that means we're shifting to the right. And that opposite is because you're trying to get back to where you kind of were originally. And the same principle works for b. So, okay, but this is basically, this slide is the key information that we need to do these problems. Let me do one example here on the video. So let's do this example. So graph, and it's just gonna be a sketch, it doesn't have to be a perfect graph, but I'm gonna graph this. 3f of 2x plus 4 minus 5. If f of x is equal to, and this is actually not that important, so you don't have to write this down. Well, you need to write the first part down, but just this, what f actually is important. These transformations work for any function, so what we care more about, so what you do need is the picture. So here is a picture of this function. It looks something like this. Okay, so here's my original function f of x. And what I want to do is I want to graph this new one over here. Okay. How do I do that? Well, I'm going to show you something called the box method. This is not the only method. So I think on the cheat sheet it actually shows both these methods. Sorry, it shows another method as well as the box method. But I'm going to draw a little box around my function. And it's not just any box, but it's a box that, sorry, I kind of meant to, let me figure this one maybe. I meant to go right through 2 there. Well, actually it kind of is any box. It doesn't matter what box you draw in theory, but in practice, you want to draw a box that kind of encapsulates the key features of the graph. So here I have, this box is going through the x-intercept, so that's nice. And it's going through 3 and -3, which isn't quite actually the tip of it. It goes actually a little bit above 3 and a little bit below -3, but that's close enough. That's kind of the nearest whole number to the top and the bottom. So I'm going to use this box, and 0, 0 is a very important point with transformation. So I'm going to keep track of that point as well. So basically, it's a box with a point in the middle. So let's think about what happens to this box. Well, this box is, and this whole function is going to be transformed with these 3 values. So let's see what those are going to do. Well, if you go back here, this tells you exactly what's going to happen. And sorry, I can't show both at the same time, but hopefully you have this in your notes. This is going to be our A value, our B value, our H value, and our K value. So based on what I just told you, this A value of 3, this is going to stretch vertically by basically multiplying times 3. That's what that's going to do. The B is going to compress horizontally. I guess I should probably abbreviate some of these. Horizontally by multiplying by, it's not 2, this is the reciprocal 1/2. Because the B and the H are kind of the backwards one. So the H is going to, the +4 is going to shift it left 4. And the K, down here, is going to shift down 5. So that's basically what we're doing with this problem. And let me, I guess also, we're going to do a new page here in a second, but basically, the reason I drew this box is it's kind of easier to think about the stretches and compressions happening to the box than the whole function. But it's going to allow me to ultimately draw the whole function. So let me actually label the box with the side length. So this is going from -2 to 2. So this length right here is 4. And this is going from -3 to 3. So this length, sorry, this height is 6. So I can see that if I stretch vertically by times 3, my new box is going to be way taller. I mean, it started out at 6, which is pretty tall. It's going to be way taller. And then I'm going to compress it horizontally, so I'm going to smush it. So what I'm going to get is this like really tall box. Its new width after that compression by multiplying by 1/2, 4 times 1/2 is 2. Its new height after stretching vertically times 3 is going to be 6 times 3 is 18. And then finally, the middle point. So these shifts, this is important. These shifts, it's easiest to think of these shifts happening just to the 0, 0 point. That point in the middle. It's in the middle of this one anyway. So this point, which started at 0, 0, is going to shift to the left and down. This is going to be now at -4, -5. So, so let me go ahead and draw this maybe a little bit more accurately on the new page. But basically, this new box gives me the information I need to graph this. So, so we're going to start, and this is just a sketch, obviously, but basically we're here at, let me do it maybe here. This is the point, -4, -5. And so this is in the middle of a box that's just 2 wide and 18 tall. So if it's 18 tall, I need to go up 9 and down 9. I'm going to go way down like So from -5, going down 9 would put me at like -13. And going up 9 would put me at 4. So it's going to look something like this. And once I have my box and my center point, I'm just going to, the idea is I'm going to sketch the same shape, but with this new box. Now, obviously, the shape is transformed, so it's not going to look exactly the same, but it's the same basic shape. Something like this. Something very thin, obviously. And that is my final answer. So I will stop the recording here.